nerds in the room here. So I'm here to talk about 3D printing because my company works in 3D printing. And so just to develop a little bit of street cred really quick, I just want to tell you about Formlabs, and then I was explicitly told not to turn it into a sales pitch, but if you want to buy a 3D printer, let me know. So Formlabs was started in 2011, and we launched on Kickstarter in 2012. We did amazingly well because basically what we did was we dropped the price of professional grade 3D printing down by an order of magnitude. So quite a few people got really excited about us. We got venture backed, and ever since we grew tremendously. We're now in our third product, and we've become one of the biggest players in 3D printing in the world, and possibly the biggest player in desktop 3D printing. And so our customers include mechanical engineers, product designers, jewelers, dentists, architects, quite a few different creative people. So about 3D printing really quick. How many of you guys actually know how 3D printing works? Oh, it's growing, it's growing. So there's a couple basic processes. I mean, there's a bunch of different technologies, but the basic idea is the same. You print a 2D layer and you stack it on top of another 2D layer, and eventually you have a three-dimensional object. So up there on the left, you have what's called fused deposition modeling, where you basically just squeeze plastic through a nozzle and you put it in a layer. This is a diagram of stereolithography. This is actually the technology we use. So you'll have a liquid resin, you shoot a laser at it, it causes it to harden, and you trace it out. It's actually really detailed. And then you have this process called selective laser sintering, where you shoot a really powerful laser at powder, and you melt it, and you make each layer that way. And with this technology, you can do cool things with metal and other materials. Now, I'm extremely excited about 3D printing, otherwise I wouldn't be in the business, but over the past couple of years, there's been an enormous amount of hype about 3D printing. And honestly, most of the hype is hype. And I'd like to tell you a little bit about where the industry came from, where it's been in the last couple of years, so that we can talk a little bit about the future of 3D printing, because there's a lot of very exciting things, but it's pretty instructive to start from here. So my first exposure, and quite a few different people's first exposure, was actually this 2011 article from The Economist talking about a printed Stradivarius. It got a lot of people really excited about it. The thing that it also did was basically even the most remote possibility of the technology suddenly became today. Everybody really wanted to embrace it. So you started seeing quite a few different things, like Meet the Machine that will print your skin and bones. And I'm sorry, we're not going to be printing your skin and bones anytime soon. Or livers or hearts. One sarcastic Reddit user actually said, printing a liver right now is kind of the equivalent of getting liver pate, putting it in a bag and saying, hey, I got your liver right here. So not quite happening quite yet. We're also not having a 3D printing food revolution anytime soon. You can ask Charlene the chef. We're also not printing our houses anytime soon, although there are some 3D printers that have tried. And unfortunately, we're not going to have a printer in every single home. There's a fundamental limitation, and one of the biggest limitations of 3D printing, of everybody adopting it, is the idea of content. And I was talking to an architect named George, he's out there in the audience earlier, who actually has been teaching CAD, computer-aided design, for 8 years. He's probably really, really good at it and probably could use our printer. The average person just can't really make content that is going to be useful to them. And so what's happened over the years, over the past couple of years, we love this meme in the company, is that 3D printing has kind of followed this hype cycle. So many of you may have heard of the Gartner hype cycle, where it looks at a bunch of different technologies and follows it across a curve. So way over on the left, you see like seedling, promising technologies that most people haven't heard of, and you start coming across the right, and the public starts hearing about them and the amazing possibilities behind it, and you start projecting all the amazing possibilities onto this technology. And so just a couple of years ago, 3D printing was right at the peak there. And then basically last year, consumer 3D printing kind of fell apart. A lot of people realized that consumers and everybody was not going to have one of these in their homes. But if you notice all the way on the right here, this is where you have mature technology that a lot more people are using. And the killer app of 3D printing right now is rapid prototyping. It's designing useful prototypes so that you can design different products. We're getting into some other applications, but one of the exciting things about this is 3D printing has probably already touched every one of your lives in an interesting way. Most devices that you use were probably designed on a 3D printer at one stage of the process. So it's interesting to think that 3D printing is 30 years old, but it's actually just getting started. So really quick history, 3D printing was actually invented in 1986 by a guy named Chuck Hull. He started a company called 3D Systems, and basically for the next couple decades, you have very expensive printers that cost well over 6 figures, but are largely used for rapid prototyping. But then after that Economist article, you start getting into the period of hype and exuberance where even kids' toys want to use 3D printing, and you have the emergence of products like the MakerBot cupcake here, where you actually assemble it yourself, and a lot of people get really excited about it. But basically at the end of 2014 and during a lot of 2015, 3D printing came kind of out of the skies and back down to reality. And so what we're seeing a lot more of now is what I call the third era of 3D printing, which is prosumer 3D printing, where you have a lot of those original technologies, like from the 80s, that are now affordable and being used by the people who can actually create content, people that we call prosumers. And you see kind of like a trend, a lot like what happened with PCs. The first people to truly use PCs were professionals and educators as well. But then on the other end, you have much more expensive machines that are able to print in new and exciting materials like titanium. They can print in a variety of different metals, and that actually gets us into the realm of additive manufacturing. So that's the three eras as I see it of 3D printing. What's next, what this fourth era, what it really does depend on are three major things. So cost, speed, and materials. So as I mentioned, some of the new technology that have come out has enabled like metal 3D printing, which enables quite a few different things. But just as a basic rule of thumb for you guys to think about the future of 3D printing is that 3D printing wins where the need for customization greatly outweighs cost. Nobody wants to pay a ton of money for a plastic fork that they're going to use at a picnic. But when you're actually replacing your jaw, there's very few things that are more personalized than that. But the oldest question in manufacturing is, what's the cheapest way I can do something and still accomplish my goal? So this is a graph we see quite a bit in the 3D printing industry. And over on the left, when you're producing only very few of something, 3D printing or digital fabrication, CNC machines, that kind of thing, they can make a lot of sense when you're producing something more unique. But as you get into larger amounts of units, as you start thinking about tens of thousands or hundreds of thousands or even millions of something, when it's exactly the same thing, it's actually very hard to compete with that. And that's one of the reasons we're not seeing 3D printing in every single product that we're already seeing. But you can imagine a future where 3D printing actually gets quite a bit cheaper. And it's already doing that thanks to companies like Formlabs, where like literally 10 years ago, a printer with the performance that we have would have cost more than $100,000. Our printer costs $3,500. So this opens up quite a few different opportunities. Now that we got rid of a lot of the hype and we're coming back a little bit to reality, start imagining the future again. And I see three major trends happening in 3D printing in the way that we make things. So the first thing is that unique will actually be common, and it's going to be expected because it will be available. And so we're already seeing some of these things actually happening. So this is a company called Normal Headphones. This is a company called Uvero, and they use digital scanning technology to actually scan your ear and make a headphone that perfectly fits into your ear. It's just the start of what's actually happening. Then you see enormous companies like Nike, Adidas, New Balance. They're actually 3D printing the soles of shoes to get higher performance, but also to make unique shoes. Right now, these shoes, you can buy them, I think they cost around $400 or $500, but you can see in the not too distant future where that actually be much more affordable to every single person. But then you have examples like Google's Project Aura, where their goal is to create a smartphone that is fully customizable, both from functionality, but then incorporating technologies like 3D printing, you can actually fully customize each individual module to the person. And then finally, one of the industries that is most already disrupted by 3D printing is jewelry. So actually our printer is used quite a bit in the jewelry industry, and I'd say most jewelry today is actually 3D printed before it's actually cast into metal. And a large portion of the management team at Formlabs has proposed to our wives with 3D printed rings, and my wife said yes, so it was good. But the part that I'm most excited about is that the most unique demand that you can make is your body, and this is where 3D printing is truly already very, very widespread in the manufacture of devices. One thing that a lot of people don't know is that 10 million hearing aids have already been 3D printed. This is almost the de facto way that hearing aids are actually produced. You see companies like Invisalign. This is a company that has $800 million in revenue every year, and they produce clear aligners that basically function like braces and straighten your teeth out, but they're produced using a 3D printing process. And then another exciting thing as printers, printing and titanium grow in capabilities is that you can actually have implants with these. So these are hip joints that instead of just having like a rod that goes inside your body, you actually have titanium components that actually can perfectly conform to your hip. But the next step is that manufacturing will be dramatically more flexible, and that comes across a couple different variables. So the first step is, and this is what the maker movement is so excited about, is that manufacturing will be democratized. So I told you about this enormous company, Invisalign, that makes Invisalign braces. Well, there was this guy on the internet who used one of our printers of his own volition and decided to do that process himself. He scanned his teeth, he made the series of aligners, printed them on our printer, and then actually straightened his own teeth. He got reprimanded by a few dentists saying that's actually really dangerous. We offered him a job, so he joined the team recently. The other thing about manufacturing under 3D printing is that it'll be more modular. So if you have this device, like the one actually we have out in the lobby, you have a factory, just a self-contained factory. If you need more capacity, you add another one. If you need even more capacity, you add another one. And so this is a stunt we pulled at the Solid conference where we built a print farm, and in 48 hours we manufactured 500 completely unique alike bracelets. So that actually, when you hold them together, if you actually had some similar interests, they'd light up in different colors, and so they can generate different conversations with people. Although it seems that rock, paper, scissors is a bit more effective. The next thing that so many people are so excited about is that 3D printing is turning the supply chain digital, and we're not talking from an inventory management standpoint. We're actually talking about emailing the digital file of a wrench to the space station, and they print the wrench that they want to use up there. And so you can imagine this like changing the way we look at so many different things. You can sometimes people talk about distributed energy distribution. You can talk about distributed manufacturing. There's one nonprofit that we've worked with that is working on prosthetics in the developing world, and all they'd need is a 3D printer in the mountains of Guatemala, and they can email the prosthetic to be printed in Guatemala. So the last thing that I like to talk about a lot, I talk to a ton of people who are saying like, okay, so this is going to be great, so I'm going to be able to scan that chair and then print it, or scan my bike and make a copy of it. And the biggest thing about 3D printing is that it enables a completely new and previously impossible type of manufacturing. It's not that we're going to make the same widget, we're actually going to make a completely different kind of widget. And my favorite example actually is this example from SolidWorks. So SolidWorks is a computer-aided, or makes computer-aided design packages. And the first model of this chair over here is very simply designed by a human. It weighs about 10 kilograms and has certain structural characteristics. As you move further to the right, you have Model 2, where you apply a computational design algorithm to make it lighter, but with basically the same structural properties, and you actually cut the weight and the material needed by more than half. But then you take that even further, and you practically completely remove the human, and you create a chair that looks nothing like a chair you've ever seen before, weighs a third of the amount of the first chair, requires a third amount of the material, so it's far more efficient, and yet has almost the exact same structural properties. And so just this idea of what's going to be happening not only in the performance of this, the sustainability of manufacturing, but just in terms of what things are going to look like is absolutely mind-blowing. And you could see that transferring to other products. The fashion industry is also getting quite excited about this, but I don't actually have an image of it. And then, you know, one of the interesting things though is that some of the most boring components are actually very exciting. So this is a fuel injection nozzle that GE is working on for jet engine turbines, and it demonstrates a concept called holistic manufacturing. So normally these actually take 20 subcomponents that you actually have to assemble that actually limit the manufacturing process. But you can print this in one go, and it has a bunch of efficiency savings, and I'm getting kicked off stage. But just because I like to dream a little bit, and I wanted to be an astronaut when I was a kid, and we need a 10x project, so our dream is to someday print buildings on Mars when SpaceX gets us there. So thank you very much.